Hello and welcome to the AEC Business podcast. My name is Arni Heiskanen, and I have the pleasure of discussing systems engineering in construction projects with an expert, Lennard van Wijk from Relatics software company. Lennard, thanks for joining us.
Yeah, good to be here and like to discuss this topic with you today. Yeah.
Can you tell us first about who you are, what you do at Relatics, and share a bit about your professional journey so far?
Yeah, sure. So, Lennard van Wijk, I'm consultant at Relatics, and Relatics is a software company in the Netherlands, and is developing and implementing a software also called Relatics, so same name, especially used in the construction business on projects to keep insights in all your project information needs. And I worked there for, I think, 5 years now as a consultant. So that means I'm implementing this software together with the processes that are used within the software on all kind of projects, Dutch government, but also like Schiphol, which is our international airport over here in Amsterdam. Different projects. I worked before at Boskalis, which is an international marine service provider, contractor, and worked on several projects around the world, mainly in ports and harbors, but also a bit offshore. So various things.
Okay. So, as I mentioned in the introduction, we will discuss systems engineering. But to those listeners who are not familiar with the term, what is it exactly and how is it relevant to construction?
Yeah, I think that's a good question because what you see is you see systems and you see engineering in the term. So I think if we split up those, if we focus on system, that's a very broad term. But for example, heating system, that is about the climate in your room. But you also know the word ecosystem, which is very broad. But a system is different components that together fulfill certain objectives or goals. And in the construction business, we see that as like bridges or tunnels or buildings, like wind farms. Those are kind of a system or different components within a system that together fulfills a certain goal. And the engineering part, which is the second part, that says that it is a process. It's a way of working or several processes together that you need to be sure that those systems fulfill these goals and these needs. So that's in general, I think, a description.
Okay. So if I understand it correctly, so the system refers to let's say, the end product and how it's put together from different components. Yeah.
Yeah, and there are a lot of businesses that use systems engineering and of course a lot of definition of systems. But I think we focus a bit on the construction part of it because you have also software systems. But in the construction part, we see mainly physical things, so things that you see and that you see around you. Yeah.
Well, why do we need systems engineering? Why is it becoming more relevant? And are there specific type of projects that you can best apply it to?
Yeah. So to start with that last one, I mentioned already some of these projects. So I think the project, it's important that there is a system defined that should be delivered. So I think that's important. And most project that uses system engineering, that kind of one-of-a-kind project. In the construction, you can see infrastructure, of course. You see energy, which is becoming more relevant these days. Offshore energy, for example, but also onshore, all kind of construction work on site, land side, but also at sea. So those are typical businesses where system engineering is applied, and it's more relevant because the contracts becomes more complex. A system is described in its whole life cycle. So it's all span of what it should fulfills. And these life cycle, they have a lot of complexity. They should have a design life of 50 or maybe 100 years for very complex structures. So large spans of life cycles, but also complex stakeholders, recognition, for example, that is increasing every year. The regulations that you should comply with, for example. And what you also see, another aspect, is that governments want to gain and to boost the involvement, to boost the innovation of the market. So they shift a bit towards contractors to boost the innovation of the contractors with their expertise. But also they gave contractors more responsibility, but in the end also ask evidence for that responsibility. So those are kind of things that changed over time.
Mhm. So is it so that, for example, housing is not something that you would necessarily need system engineering on?
I think that's a good question. It also depends on your own context. So what you see is you can have a very simple system, so to say, but you have to implement it in a complex environment. So it's not only that you define it on the system itself, but you also take into account the environment where it is placed within, or the amount of stakeholders, for example. So we have, as Relatics, we have clients that also do housing. But what you see is that the system engineering part is becoming more involved and more important and having more benefits where it is when it having more complex components.
Mhm. Well, as we discussed already, you're working at a software company, and you have software for these kind of things.
Yeah.
Can you discuss your model-based approach to systems engineering, and what does it mean in practice, and how is it different from the more traditional methods?
To show you what the traditional way is related to the way how we do it when we implement system engineering with Relatics. What I show now is just a visual of a construction site. So what you see is a bridge that is constructed, and you see an head office on the left-hand side, an on-site office, and all kind of people working together, or they think that they work together. And what we see is all kind of information that flows around these projects. First of all, of course, in the head office, when the project was, when there were plans made and all kind of documents written to gain the project and to plan the project, etc. All kind of decisions made there in documents, in design files, but also on the construction site itself. All kind of documents are written, Excel sheets with proof, with all kind of measurements, cut files that are produced. And what's important about this is that within these documents, all kind of hidden there are all kind of hidden interdependencies. So let's say that there is in the head office a discussion with different parties together saying, okay, we had a discussion, we changed the requirement for this bridge now, and we say that a different condition is changed from now on, etc. That has all kind of consequences on the other documents that you see in these in screed lines. And in a traditional way, we know that. It's not that we do not know that. We know that it has consequences, but we are not aware of all places where this change can have consequences. And that's something that we do with Relatics, where we transform this traditional way in a way where we keep track of all the different requirements and verification of functions, etc. All the different functionalities and information needs, we relay them between itself. So we create the interdependencies between the different requirements, the different objects, part of the scope, etc. itself. But of course, is what we do is together with the project team say, okay, what are the dependencies that you know, and we make them clear and make them in practice and make them working, so that when there is in the head office a discussion that the requirement is changed, that immediately the man that is on the field sees that has consequence on the risk profile, maybe on the work that he is working on. So that's in general what the Relatics method adds to the traditional method. And of course, we have all kind of metadata needed to understand these systems, the information. But I want to highlight is that we are not aiming to have all this information in Relate. So we are not replacing your Outlook. We are not replacing your Excel in all kind of, and your COD files. No, we say, okay, show us those disciplines working together, and maybe they are stored in different files or different software platforms, but at least make these relations visible. That's it in general.
Okay, and that's where the name comes from. Sure.
Of course, yeah. It is what it's named.
Yeah, that picture kind of reminds me of a knowledge graph that is used in AI.
It's very close. Yeah, sure, yeah.
Okay. If we think of let's say a project like a bridge or a tunnel or something like that, how do you get involved in a project like where do you start?
Yeah. So first, from the Relatics side, on when it is on a large project, especially in Europe, so we see we are invited to join a tender phase of, for example, requirement management software. So we start with writing a plan and a bid, etc. So that's on large project, especially in Europe. But we also see that clients of us, like for example contractors, they bring their Relatics implementation together when they maybe in a joint venture start their work in the project, even in tender stage already. So there are different ways how Relatics can come on a project, but it can also be that there is a project professional, both or either on the client side or maybe on the contractor side or at an engineering firm that's say, okay, I have experience with other projects before that work with Relatics, and I want to try to if we can implement that here as well. So we also see kind of that project professionals brings Relatics together in their suitcase when they go from project to project.
You said that you are not replacing existing systems, but what kind of information or technical architectures do you see when you come join a project?
Yeah, so what we often see is that, of course, in most cases there is a contract. So and there's a lot of paperwork. So maybe it's very simple. Those are Word or PDF files, just in an information storage, like maybe in a SharePoint system, but even sometimes on a hard disk. So it can be from different levels of how the information is stored and maintained. But we see information mainly in Word, PDF files, Excel files, for example. But what you often see is document management systems that are partly or for some processes in place. And we see, of course, things like planning software and software for designs and construction, etc. So those are the software packages that these companies use already, maybe for decades already. So that's not something new, and we want to, when we come on a project, we always make a kind of an overlay. So how is Relatics fit in within these different projects and different programs, I have to say, and what is then the function of Relatics? But maybe even it can be that there even is already a requirement management software in place, for example, that we have to connect with, or a data warehouse, or where we have to exchange with. So these kind of questions we ask always when we started the project.
So is your software cloud service or on premise?
No, it's fully a cloud service, so it is a SaaS solution. Yeah.
Okay, yeah. So who in a project would use Relatics and how?
Yeah. So what we do is we within the project, we want to, together with our contact person on the project, we want to get insight on what kind of disciplines are involved in the project. And our goal is to have all these disciplines in some sense involved. There are, of course, disciplines like in design and engineering department, which is very much involved because it's very close to these system design and construction, etc. And there are maybe disciplines that are more at a higher distance, at a distance that's more supporting the project, I have to say. But at least we want to also incorporate them, because what's the power of Relatics is that it makes this information visible to all project members, and we see as Relatics all project members as contributing to these goals and these objectives of the project in the system. But they, of course, do that in a different level, in a different sense. So some are working on a daily basis and some on a monthly basis. But in general, we see contract managers, we see design engineers, project managers, of course, but also construction workers that are work outside. They want to check, okay, what I have to do, etc.
So everybody who wants the access can get it, I assume.
Yeah, it's not. I want to highlight that's not something that the expert brings in, and then people asking the expert, okay, can you do something for me? No, that's not how Relatics work. Relatics is something that you can easily give your project members access to, and of course you can do something with roles and rights, etc. Who can see what, etc. And who can edit what, of course. But what we see is that if you're a project member, then you have, at some sense, you hold some knowledge of that project, and you can, in some sense, contribute to the objective and the goals of that project in that system. Maybe you see something, maybe you see a risk on your screen that you think, okay, maybe that risk cannot occur anymore because this happened. It's maybe not your responsibility to do, but because you see it, you can act like. So we like to work in an open environment as much as possible.
Because some of your previous clients or users are recommending Relatics, it means that they have seen some benefits. What kind of benefits are your clients or customers typically seeing?
Yeah, so I want to highlight that a benefit what we often see is in project things changes. It always, one thing that changes not is that it changes, that it is changing. So and the benefit to see we see is when things are changing, then Relatics shows its strength, because for example, contract manager that takes over from another contract manager, they see all these changes that has been made in the contract, but also the consequences of these changes. Of, for example, a design engineer that make a big, huge design decision that is a new way of working within the project. They want to know, okay, can we do that? What is the impact of this, etc. So those are the people that say, okay, we should track all these dependencies to make my work, that I can do this work and make these decisions. But also the contractor. So if you are a system owner or a government, and your contractor benefit from you using systems engineering, because they receive the information in a structured way, and you can also share the information that that's part of the project. So if you define requirements, for example, you share them with your contractor, they know what to do, and you can predict what you get back. for example. So those are different benefits or different levels. I mentioned already people that are, for example, taking over for someone else. So someone moves to another position or left the project, or even the entire company. Then someone else can take over the same day without searching. Okay, what's the paperwork? And in the end, when you deliver your project, I know from projects where they have kind of large containers, air conditioned, with climate control, with big pillars of paperwork only for delivery. And in the end, there is a team like 2-3 months together coming in. So not the same team, but a team coming in to do this entire delivery. So that's not something I think is very efficient. And that's something that we want to prevent.
Okay, so efficiency and probably risk management are one of those benefits that, and also you have a track record, or you can have an audit trail of what's happened on the site.
Yeah, sure. So because of in the systems engineering methodology, the traceability is key. So everything should be traceable towards the goals that you. So the system has a certain objective or goals that you want to, and everything should be traceable to that. And the stakeholders, they have needs for this system. So it's or traceable towards these project goals, but also towards the stakeholder needs. And it's also traceable within Relatics. That's another level of traceability. In Relatics, for example, who did what. So you always can see, even from years from way back, what has changed and when and how and even with what kind of reason.
All right. So I think that's a very exciting concept, and obviously it works, as you have shown. So, but what's one thing you wish more construction professionals understood about systems engineering?
I think that's a good question, but because what I want to mention is that it is teamwork, and of course, yeah, that's kind of obvious, but it's like sports. So you win as a team, and sometimes I have discussions with people, and they say, okay, I have to do a lot of work now, and yeah, that it's true. Sometimes it is a lot of work, and why do we have to define all these relationships, etc. But you should see it as a sport, as a team sport, where you in the end receive all the benefits together. But there are project phases that you have to do a lot of work, and that you should believe in the goal. That in the end you're gaining, you're harvesting the benefits, and maybe another team that takes over. If you do an extensive tender in your project and you win that, and you have a winning bid, and another project team takes over, and you can imagine if they takes over, they can start with a fully system in place, not only a software system, but also defined system where they benefit a lot from having a quick start in their project. But the tender team, they did a tremendous job, but it was also an extensive job. And that's something that we don't, that's also the story that we have to tell. It is hard work, also, especially for some individuals, and that work is not, and also the benefit is not spread equally over all people. So do it as a team, and as we, to know what the benefit is, also tell each other how you have benefited from these processes.
Yeah, I think communication is essential in any kind of endeavor that you have to you will take. I'm sure that based on this, many of our audience is eager to learn more. So, how can they find more information? And perhaps if they want to connect with you, how can they do that?
Yeah. So it's a bit related to the previous question. I want to say to them, you don't have to be a system engineer to to do something to perform process of systems engineering. And also you don't have to have a system engineer function or role in your project to perform these kind of processes. So you can do it yourself. On our website, relatics.com, we have white papers available that you can download to perceive some and to read it and to see what these different processes are. There is an interesting book, Pioneers of Systems Engineering, and that's a book where all kind of project professionals share their knowledge and their experience with system engineering on various construction projects. And I want to highlight in this session that if you contact Relatics at contact@relatics.com, so contact@relatics.com, and you mention AEC Business, you can receive a free copy of this book to start your work with system and read more about how it has been performed in the past also. So you can download the information from our website, stay and keep in contact with Relatics, but always keep in mind, you can start on your own. You don't need to change your entire project team or even go to your contract manager to allow you to perform a system engineering project. You can start at your own.
Okay, that was a good extra benefit from being in our audience. I'm looking forward to that, and I will definitely read the book. Lennard, it has been a pleasure talking to you, and I'm sure that you have a lot of work in the future.
Yes, yeah. And again, thanks for discussing this part and success with your story on AEC Business.